So what about if we're multiplying two numbers in radical form together? Something like 3 radical 12 times 4 radical 6. Well, when we're multiplying numbers, remember we can move numbers around. Like 3 times 4 is the same as 4 times 3. That's because multiplication is commutative. So what we can actually do is move this so that all of the whole numbers, all the integers are together, so that 3 and 4 are together. And the square roots are also together, so the square root of 12 times the square root of 6. And so basically what we're doing is we're just multiplying those numbers that are on the outside of the radical together, and the numbers that are on the inside of the radical together. So 3 times 4 is 12, and 12 times 6 is going to be 72. Remember, keep that inside the square root. And then from here, all I need to do is simplify just like I did before. So how can I factor that 72? Well, 72, 4 goes into 72, and that's a perfect square. So 4 and 8 is left over. Excuse me, that is 4 times 18. So 4 times 18 is 72. And don't forget to bring that 12 down. Okay. And then can I break 18 up anymore? Well, I can. I mean, 9 goes into 18, and 9 is a perfect square. So square root of 9 times the square root of 2. And let's bring down the 4, bring down that 12. All right, and can I break down 2 anymore? No, 2 is a prime number. It's got no other factors. So let's finish this out. This will be 12 times 2 times 3, and my leftover square root of 2. So that means this is going to be 12 times 2 times 3 is 72. So this is 72 square root of 2. Now, if you'd prefer to do this the other way, something similar to what we saw over here or here, that's fine too. Just keep in mind that I'm going to do it by looking for perfect squares, and as long as your answer comes out to the same one that I have, you're okay. Pause the video here and try and do the next two problems by yourself. Let's take a look. So the square root of 3 times the square root of 6, well, there are no numbers on the outside of the square roots, so I'll just multiply the numbers on the inside. 3 times 6 is 18. Keep that under the square root. 18 breaks down into the square root of 9 and the square root of 2. The square root of 9 is 3, and the square root of 2 is prime, so that gets left over. So 3 square root 2. As to the last one, there's no number out here, but there is one here. Well, I suppose we could put a 1 out in front. So this is 1 square root of 3 times 5 square root of 12. And that makes sense because 1 times square root of 3 is just the square root of 3. So putting that 1 there does not change the value of this expression. So then I can multiply the coefficients on the outside. So 1 times 5 is 5. I can multiply those numbers under the square roots there. So 3 times 12 is going to be 36. Now I ask myself, are there any perfect squares that divide 36? Well, wait a second. 36 is a perfect square. It's 6 times 6, or 6 squared. So I can write this as 5 times 6. And there's nothing left under the square root, so I don't have to draw it. So just 5 times 6, which is 30. One last thing we're going to talk about before we go. What about if you square a square root? Well, we know from up at the very top of our paper that when you square a number, you're multiplying it by itself. So it might be useful to rewrite this as the square root of 5 times the square root of 5. And now, well, we just did this kind of problem before. I multiply the insides of the square roots, so square root of 5 times the square root of 5 will be the square root of 25. And I don't even need to try and break that down because the square root of 25 is just 5. That's it, just 5. Pause the video here and try and do the next problem. The work is going to pop up on your screen in 3, 2, and there it is. So the square root of 7 squared is just 7. And so we're starting to see a pattern develop here, right? The square root of 5 squared is 5. The square root of 7 squared is 7. Let's try a couple more problems with numbers out in front of those square roots. So again, I'll rewrite 4 square root of 5 squared as 4 square root of 5 times 4 square root of 5. And then multiply my numbers outside the square root. So 4 times 4 is 16. 5 times 5 is the square root of 25. And then I don't really need to try and break this down because I know the square root of 25 is just 5. So I'll rewrite this as 16 times 5, or 16 times 5 is 80. 80. Pause here and try and do the next one for yourself. The work is going to pop up on the screen in 3, 2, and there's the work. And again, we're starting to see some sort of a pattern here. It looks like when I square these numbers, the number on the outside of that square root gets squared, but the number on the inside of the square root just loses its square. I guess it's radical, I should say. See how this 2 comes down here, but doesn't have a radical anymore. So what will always happen when you square a square root, and why? And so looking at these observations, it seems like when you square a square root, you are canceling out the square root. Remember, that's because up at the very top, we said that squaring and square roots are inverse operations. So they kind of cancel each other out. And so when I look at something like the square root of 5 squared, I can just say those are inverse operations. The square root of 5 squared is simply 5. It gets a little tricky when you look at something like this, but the 4 square root of 5 squared, we can kind of distribute that squared and say, well, that's really just 4 squared square root of 5 squared. Those cancel each other out. 4 squared is 16, so we're left with 16 times 5, which we saw before was 80. 80. So throughout this video, we have remembered our perfect squares, learned what a square root was, learned how to estimate a square root, learned how to use a square root on a calculator, learned how to simplify a square root, did some more practicing simplifying square roots and radicals, multiplied square roots, squared square roots, and made a generalization about what happens when we square a square root. Wow, a lot of stuff packed into this video. So make sure you go back, rewind, rewatch anything that you missed or confused on. Make sure you're taking down these notes, and make sure that you're ready to use them for your homework or next time you come to class. I'll see you then.